I have two different examples in this video where I'm going to multiply. And this first one that I do, I'm actually going to do it two different ways just to show you your options. So your first option, you can just multiply straight across. If you remember how to multiply regular old fractions, it's the same exact thing here. So if you decide to multiply straight across, I'm going to start with my coefficients. So in the numerator, I would do 2 times 15. In the denominator, I would do 3 times 8. So we get 30 over 24. Now I'm going to move on to my variables and my exponents. So in the numerator, I have x to the fourth times x squared. You always add your exponents. So 4 plus 2 would give me 6. In the denominator, I have x squared times x to the third. Adding my exponents would give me 5. And then in the numerator, I just have 1y to the fifth power. And then same in the denominator, I only have one more y. That one is squared. So I just bring those along with me. Now you can start simplifying. So if you have 30 over 24, that can be reduced. Six goes into both of those numbers, so I'm going to divide by 6. Now I have x to the sixth over x to the fifth. You always subtract when you are dividing. You subtract your exponents. So 6 minus 5 is going to give me x to the first, or just x. You can write x to the first, but you normally won't see it there. And then we have y to the fifth over y squared. Again, subtract your exponents. 5 minus 2 gives you 3. So this is one way you could write it. You could also have that 5 over 4 off to the side, multiplied by xy to the third. So that's one way to do it. If you are more comfortable just multiplying straight across, that's fine. This other way that I'm going to do it, I'll be honest, when I was first learning to do this a long time ago, this was confusing to me for some reason. So if it's confusing to you, that's okay. If you like it this way, then do this way instead. So what I like to do is just start simplifying right away instead of waiting until after I've multiplied. So if you look at your coefficients first, you have a 2 over 3 and a 15 over 8, but you can look diagonally as well. As long as there's something in the numerator related to something in the denominator, anywhere in the numerator, anywhere in the denominator, you can reduce those fractions. So first I noticed that there's a 2 somewhere in the numerator and an 8 somewhere in the denominator. 2 over 8 would reduce to 1 over 4. So I can go in and just cross out the 2 over 8 and turn it into 1 over 4. I'm going to do the same thing with 15 over 3. I can do 15 divided by 3, which is 5, or if you look at it this way, 15 over 3 reduces to 5 over 1. So now my numbers get a little smaller right away before I multiply straight across. I can do the same thing with exponents if I want. So if you notice you have an x to the fourth over x squared, you can immediately reduce that, or you can multiply straight across like I did the first time. So I'll leave that up to you. I already showed you how to do this problem one way. So once you do this reducing, you can then multiply straight across and you just have smaller numbers and smaller exponents to deal with. So this second one, I'm just going to show you another example. I'm going to do what I just did, where I start to reduce before I do any multiplying. So I notice that I have 4 over 6, that can be reduced. I also have 42 over 28, that can be reduced. You can also look diagonally and you can see that there's a 4 over 28 and a 42 over 6. So you can change your perspective and look at it different ways, but I will do 4 over 28 and 42 over 6 just because those look easier in my mind. 4 over 28 reduces to 1 over 7. And then I've got 42 over 6, that reduces to 7 over 1. So you may notice that you have a 7 over 7 here. Those will also reduce to just 1, or they'll cancel, however you look at it. So those are now gone. So I've done a lot of work ahead of time instead of multiplying and getting those bigger numbers. So now I'm going to reduce those variables with the exponent. So I have a w to the third in the numerator, and I have just a single w in the denominator. That's technically to the first power. So if you have a 3 over a 1, remember you always subtract your exponents. So that becomes w squared. Now I also have a t to the fourth and a t to the seventh in the denominator. So something to remember, you won't write your final answer with any negative exponents. So what would happen here is you do 4 minus 7, which equals negative 3. Now, instead of writing t to the negative 3, what happens is you can just make sure that that variable moves to the denominator, and then it becomes a positive exponent. So 4 minus 7 gives me negative 3. But if you get a negative exponent, make sure in your mind you think, okay, that just means that I'm going to write t to the positive third in the denominator, and I'm good. And then you've got your x times x squared, which will get multiplied in the numerator. So we have a w squared up top. We have x times x squared. That's x to the third. In the denominator, the only thing I have left is t to the third. So that would be your answer. Now I'll explain that negative exponent again really quick. If you didn't cross those out and you just did t to the fourth over t to the seventh, and then you did your subtraction, you would have this, but you don't want to write your final answer with negative exponents. Your question will usually say to use all positive exponents. So that means you're going to move the t to the third to the denominator. Because that negative exponent is indicating a reciprocal. So that's where we got our answer.